It's a brutal summer afternoon. The kind where the air inside your home feels stuck, heavy, almost like it's pressing against your skin. The fan is spinning above you. The electricity bill is rising in the background. And somehow, you still don't feel comfortable. Here's the strange part. That ceiling fan above you is not cooling the air at all. Not even a little. So why does it sometimes feel like it's saving you money, and other times feels completely useless? If you've ever looked at your electricity bill in summer and thought, this makes no sense, you're not alone. Most homes are using ceiling fans in a way that quietly wastes money without anyone realizing it. What you're about to see is not a gadget trick or a hack. It's simple physics that most people never get explained properly. And once you understand it, the way you use cooling in your home changes completely. Every summer, the same pattern repeats. The heat rises. The fan goes on. The AC follows. And the electricity meter keeps spinning faster than expected. People assume the solution is more cooling power, a stronger fan, a colder AC setting. But the comfort still doesn't feel right. Because the real issue is not the temperature of your room. It's how your body interacts with the air inside it. Most people believe a ceiling fan cools a room. It doesn't. If you sealed a room completely, turned on a fan, and left a thermometer inside, the temperature would stay the same. In fact, over time it can even rise slightly because of the motor heat. So if the air is not getting cooler, why do we feel cooler? The answer is not in the room. It's on your skin. Your body is constantly releasing heat. On a hot day, it tries to cool itself through sweat. But sweat only works when it can evaporate. Around your skin, there's a thin, invisible layer of warm, humid air that builds up and just sits there. No movement, no airflow, just trapped heat. This layer is what actually makes you feel sticky and uncomfortable, even in a normal room. A ceiling fan's real job is not to cool the air. It's to destroy that layer. When the fan spins, it pushes air across your skin. That movement removes the warm layer sitting on your body and replaces it with fresh air. Now your sweat can evaporate properly again. And when sweat evaporates, it pulls heat directly from your body. This is why you feel cooler without the room changing temperature. It's a perception shift, not a temperature drop. Now here's where things get interesting. A typical air conditioner can consume thousands of watts. Running it for long summer days can quietly add hundreds of dollars to your monthly bill. A ceiling fan, on the other hand, uses the same energy as a light bulb. But there's a catch most people miss. A fan only saves money when it allows you to raise your thermostat. If you keep the AC at the same setting and just add a fan on top, you are not saving anything. You are actually adding extra cost. This is where most households go wrong. They turn on the fan and leave the thermostat untouched. So the AC keeps working just as hard, and the fan adds extra electricity use on top. No savings. Just more consumption. Even worse, many people leave fans running in empty rooms. That's pure waste. Air movement with no one benefiting from it. There's another hidden limitation. Ceiling fans depend on evaporation. But when humidity gets extremely high, your sweat cannot evaporate efficiently. The air is already full of moisture. In that condition, the fan is just moving hot air around. It still feels like movement, but the cooling effect drops sharply. That's when people mistakenly think fans are not working. Ceiling fans have been around for over a century. Early electric designs were simple motors attached to blades, designed for basic airflow. They worked, but they were noisy, inefficient, and limited. Most homes used them because they were cheap, not because they were smart. But the real shift came much later. Older fans used AC induction motors. Strong, but inefficient and noisy. Modern fans use DC brushless motors. These reduce energy loss, run quieter, and can use up to 70% less power. They also allow finer speed control instead of just a few rough settings. That means you don't have to overrun the fan just to feel comfortable. You can match airflow to actual need. Blade shape also changed everything. Modern fans are designed more like aircraft wings. Curved edges create smoother airflow, less noise, and more efficient movement of air. Instead of just spinning air, they guide it. That means better comfort at lower speeds and lower electricity cost. Here's a detail most people never use. Direction matters. In summer, the fan should spin counterclockwise. That pushes air downward and creates cooling airflow on your skin. In winter, it should spin clockwise at low speed. that helps circulate warm air trapped near the ceiling. One small switch changes how the entire room feels. This is where real savings happen. If you combine a fan with a slightly higher thermostat setting, your comfort stays the same, but energy use drops significantly. Even a small adjustment makes a noticeable difference over time. But only if the fan is actually supporting the cooling system, not just running alongside it blindly. So here's the practical part. Use fans only when people are in the room. Adjust direction based on season. Raise your thermostat slightly in summer instead of fighting the heat with AC alone. And never assume the fan is cooling the room. It's cooling you, not the air. That shift in thinking changes everything. When used correctly, something interesting happens. The room doesn't need to be freezing anymore to feel comfortable. The AC runs less often. The fan does more of the comfort work. And the electricity bill slowly starts to reflect that change. Not dramatically overnight, but consistently, month after month. The surprising truth is this. Nothing about ceiling fans is new. The physics hasn't changed in over a century. What changes everything is understanding what they actually do. Not cooling the room, cooling the person. If you want more simple systems like this that quietly reduce home energy costs, there's a lot more to explore. And the next one might be even simpler than this. And this is where most people get surprised, because once you start paying attention, you notice how small adjustments change the entire feeling of a room. Not dramatic changes, not expensive upgrades, just simple control over airflow that was always there, but never really understood. For example, people often assume that running the fan faster will always make them cooler. So they push it to the highest setting and leave it there for hours. But higher speed doesn't always mean better comfort. At a certain point, the air movement becomes too strong, and instead of gently carrying heat away from your skin, it starts creating discomfort, especially when you're sitting still. Your body doesn't need a storm. It just needs steady movement across the surface. There's also something interesting that happens when you combine ceiling fans with natural airflow from windows. If you open windows on opposite sides of a room, even slightly, you create a pressure difference. Air begins to move naturally without any mechanical help. Now when a fan is running in that environment, it doesn't just push air in circles anymore. It reinforces that natural flow. That's where comfort becomes noticeably different. The room stops feeling sealed. The air stops feeling used. It feels lighter, even though nothing about the temperature on paper has changed. This is also why two identical houses can feel completely different in summer. One is sealed and stagnant. The other is quietly breathing. But there's still a hidden issue most people don't consider. Heat doesn't only come from outside. It builds up inside the house too. Appliances, lights, even chargers left plugged in all contribute small amounts of heat. Individually, it feels irrelevant. But over time, especially in a closed room, it adds up. So when a fan is running, it is not just dealing with outdoor heat. It is constantly fighting against internal heat sources as well. That's one of the reasons older homes with poor insulation feel harder to cool. The system is not just reacting to the weather. It is reacting to everything inside the walls. Now think about how most people use cooling systems during peak heat hours. The pattern is usually the same. The room gets uncomfortable, the AC goes on full power, and everything is closed tightly to keep the cold in. But what actually happens is a slow cycle of overcorrection. The room gets too cold, the system shuts down, the heat builds again, and the cycle repeats. A ceiling fan can smooth out that cycle in a way that is often overlooked. Instead of waiting for temperature swings, it maintains a steady layer of comfort between those cycles. Not by changing the air itself, but by changing how your body experiences it. And this is where perception becomes more important than measurement. Two rooms can show the exact same temperature on a thermometer, but feel completely different depending on airflow. One feels still and heavy. The other feels open and breathable. That difference is what people are actually paying for when they run fans or air conditioners. Not just degrees on a screen, but how those degrees are experienced by the human body. Once you understand that, you start seeing why so many energy-saving opportunities are missed in everyday homes. It's not that people don't care. It's that they are measuring the wrong thing. Even the placement of a fan changes outcomes more than people realize. A fan positioned too high above seating areas loses efficiency. The airflow disperses before it ever reaches the body. Too low or poorly centered, and it creates uneven circulation, where some parts of the room feel active while others remain stagnant. When air is moving gently, the brain interprets the environment as less intense. Even if the room doesn't swing between extremes as much. It settles into a more stable range that feels easier to live in, even during peak summer days. What's interesting is that none of this requires new infrastructure. No renovation. No expensive upgrade. No major change in equipment. Each one feels minor alone. Together, they change the entire behavior of a home during heat.